Hey guys, so this is just the next recording of the questions we did on Monday. So in this, there'll be a little bit of algebra that we did towards the first half of the grind, and then second half of the grind was all to do with functions. So let's get started. So first question. This question caused a little bit of confusion because this here is actually a divide, not a plus. It looks a little bit like a plus, but that's basically what was causing the issues. So yeah, let's get started. When you see something like this, it's very complicated. It doesn't look fun. What you would do if you just went straight off the bat is if you're dividing, you would flip this upside down and multiply, but everything is just a bit messy. So what we noticed in the grind was that you can break everything down into simpler things. So if this one right here, if I'll do it in red, this is actually the difference of two squares. So we know that formula, that's just the square root, so x plus the square root, x minus the square root of this term here. So that's x plus 3, x minus 3. This one down here we can just factorize. So that's 2x, x, 5, 3, minus will give us minus 11. So that up there can be written as 2x squared minus 11x plus 15. This one here, we can just take out the x. That's x into x plus 3. And we'll do this one in blue. Down here, down here, we can just take out the 2x squared. So that's 2x minus 5. So rewriting all this, all those two fractions are actually the same as x plus 3 times x minus 3 over 2x minus 5 times x minus 3 divided by x times x plus 3 over 2x squared times 2x minus 5. So when we're dividing, we want to swap that to multiply and swap this fraction upside down. And so that'll give you basically the same answer as dividing. So if we do that, x plus 3, x minus 3 times 2x minus 5 times x minus 3 multiplied by 2x squared times 2x minus 5 over x times x plus 3. We know that when we're multiplying fractions, we multiply the top with the top and the bottom with the bottom. So that's pretty easy. That's x plus 3 times x minus 3 times 2x squared times 2x minus 5 over 2x minus 5 times x minus 3 times x plus 3. So I've just written everything on one line, everything multiplied together, all on one line. So now, like I was saying before, you can go ahead and cancel things. So anything divided by itself is just 1. So 5 over 5 is just 1. And so that's the same for x minus 5 over x minus 5. That's equal to 1 as well. So knowing that, what we can actually do is cancel some of these stuff above and below. So you see here we have an x plus 3 and an x plus 3. Those can go. We have an x plus 3 and an x plus 3. That can go. We have a 2x minus 5, a 2x minus 5. That can go. And what we're left with is 2x squared over x, which is the same as 2x times x over x. And we can do the same trick. The x just goes with the x. And our final answer is 2x. So that's your final answer. That's your question done. That divide, it looks a little bit like a plus. That's what was causing confusion the last time. But takeaway from this question is when you're dividing by a fraction, this fraction here, swap the multiply and flip the fraction upside down. So yeah, on to the next question. This question was another algebra question, and basically what we took away from this question was what the word expansion meant. So expansion is kind of like the opposite of division. It's kind of a little bit similar to multiplication, and what it means is when you see two brackets next to each other like that, you're basically going to multiply them all out and get one big term at the end. But this question reads, in the expansion of 2x plus 1 times x squared plus px plus 4, where p is just any positive number, not including 0, the coefficient of x, so here we went over what coefficients were as well. So if we have a quadratic expression like this, 2x squared plus 2x plus 1, basically coefficients are the thing multiplied by a term. So we would say that 2 is the coefficient of the x. And likewise here, this is actually just 1. So 1 is the coefficient of the x squared. And the 1 at the end here, that's just a constant. So that's just a little bit of terminology that you need to know for questions like these. But it says the coefficient of the x is twice the coefficient of the x squared, and find the value of p. So we learned that expansion means multiplying things out. So, well, first we'll rewrite what we know. That's 2x plus 1 times x squared plus px plus 4. Then we'll multiply everything out. So the way I would do it is this term by this term, this term by this term, this term by this term, and then swap. Then do this term by this term, this term by this term, and this term by this term. But you can do it any way you like. I know you guys, I think, we're splitting up the fraction and multiplying each term by all of that, which is the exact same, but yeah, whatever way you like. So I would do 2x times x squared is 2x cubed, 2x times px is 2px squared, 2x times 4 is 8x, 1 times x squared is just x squared, and 1 times all of this is just the same thing. So that's x squared plus px plus 4. So this is what we would call the expansion of this thing up here. So basically it's multiplying everything out and getting one phrase, kind of one line for it. And what I was saying to do was, what I would do next is put your highest x first, put your next x then, x squared, then your single x's, and then your constants. So once we've written our highest x first, next x second, third x third, whatever, keep going like that, we can group their terms basically together. That's what it allows us to do. So 2x cubed plus, we can take out this x squared. So these two terms together are actually the same as x times 2p plus, imagine the 1 there, 2p plus 1. And both these terms are the same as x times 8 plus p plus 4. And we can see this if we actually just do a little aside over here. If we just write 8x times 8 plus p and we multiply that out, that's just the same as 8x plus px, which is what we had at the start over here. So basically, I would use the term taking the x out. It's basically just doing like a reverse expansion. So yeah, now we can see our coefficients. So this here would be the coefficient of the x, and this here would be the coefficient of the x squared. So the question tells us that the coefficient of the x, this one, is twice the coefficient of x squared. So this one here is twice this one. So that means if this were a and this were b, that means a equals 2b. And a helpful tip is that look out for the word is. Wherever you see the word is, that means equal to. So the coefficient of the x is 2 times the coefficient of the x squared, which is b. So wherever you see is, that's kind of equal to. So we can write that then. We can say that 8 plus p is 2 times 2 plus 1. And we can expand out the left-hand side, or the right-hand side. That's actually 4p plus 2. Then we can group our p's on one side and our constants on the other. So that's 6 equals 3p. 6 over 3 equals p. 2 equals p. And so that's your final answer. That's what they want, the value of p. So yeah, takeaways from this question: what the word expansion means, what the word coefficient means, and where we see is, that's kind of equal to. So yeah, on to the next question. So what we did next, I think, was this long division. And if I've forgotten any questions that we've done, let me know and I'll do them in the next video. So yeah, so this long division, we can rewrite this, divide this by this. So if we write minus 6x cubed minus 4x squared plus 44x plus 56, and that's divided by 2x plus 4. So doing long division, first term into the first term. So 2x into minus 6x cubed is minus 3x squared. So then this times this, minus 3x squared times 2x is the exact same. Minus 3x squared times 4 is minus 12x squared. We're going to change our signs. Then we're going to add the two lines together. So these two terms will cancel. And our line here is 12x squared minus 4x squared, which is actually 8x squared. So then we can bring down our next terms, 44x plus 56, and we go back to our first term, so 2x into 8x squared. So 2x into 8x squared is 4x. 4x times 2x, 8x squared. 4x times 4 is 16x. Change your signs. Add your two lines together. These two are going to cancel. Here we have 44x minus 16x, which is 3028x, and we can bring down our final term. Back to 2x times 28x, that is 14. 14 times 2x, 28x, and 14 times 4 is 56. Now you can finish it off like this and change your signs and cancel, but you're just left with 0 at the end. So when we divided 2x plus 4 into this expression here, we got this as an answer. And what we learned in the next half of the grind was that when a factor divides evenly into an expression, sorry, let me rephrase that. So what we learned was when something like this divides evenly into a cubic expression or quadratic expression, that means it's a factor, because factors multiplied by each other give expressions. So if this was our factor and this was the other factor that we found, 14, so this was our answer at the end, these two multiplied together will give you your original expression. So you'd call this a factor, and if we factorize this out further, whatever answers you get here, these are made up, but x plus 3, x minus 3, those would be your other factors. So, yep, takeaways, basically how to do long division, and we'll learn later again that this is a factor if it divides in evenly. Okay, so on to the next question. So, next question was, given that x minus c plus 1 is a factor of x squared minus 5x plus cx minus 6b squared, express c in terms of b. So, like I was saying before, we learned that if factors multiplied by each other give expressions, so we know that if this is a factor of that, it can divide in evenly. So it divides into this with a remainder of 0. And we can use that to figure out what c and b are, or just express them in terms of each other. So we're dividing this, so that's under the line, x squared minus 5x plus 5cx minus 6b squared, and above the line is x minus c plus 1. So long division, first term into first term, x into x squared is just x, so x times x is x squared, x times minus c is minus cx, and x times 1 is just x. We're going to swap our signs, and we're going to add our two lines together. So those two terms will cancel, and we'll just rewrite So I'll write this term first. I'll write minus 5x. We can also write plus 5cx plus cx minus x. And we can bring down our term 6b squared. So here you can see you can add things that have the same x. So 5x and x, those can add together and we'll get minus 6x. And we have cx and cx, so we can add those together. That's plus cx minus 6b squared. So like I said before, you can actually take out your x, that's what I would call it, or just do like a reverse expansion. So x times minus 6 plus 6c would give you the same answer as this up here. And then minus 6b squared as well. And so basically we just go back to our rules again. The first term times the first term. So x divided into x times minus 6 plus c plus 6c will actually just give us what x is multiplied by. Because, yeah, when we write it up here, it'll multiply by x, and that's just the same x times whatever we have up there. So we can just write what's in the bracket, minus 6 plus 6c, and then multiply back. So this times x is the same, x times minus 6 plus c, and all this in the brackets times c. We can just do this on the side, so c times minus 6 plus 6c. That's actually plus 6c minus 6c squared. So we can write that here, plus 6c minus 6c squared, and all this in the brackets times just 1 is itself, so minus 6 plus 6c. We can change our signs, minus, minus, plus, plus, minus, and we can add our two lines together. So this is just the exact same. So that'll cancel. We can rewrite, see what we have. So minus 6c plus 6c squared plus 6 minus 6c minus 6b squared. So I'm just writing, that's at the end, I put that at the end, and I'm just rewriting all of these. So yeah, we know we've divided it into the expression, so we've divided x minus c plus 1 into our expression, and we know that since it's a factor, and factors multiplied by each other give an expression, the reverse of that means factors divided into expressions give a remainder of 0. And basically how I can show you this is that x minus c plus 1 we already told was a factor, and because we divided in evenly, this is also a factor. So these two multiplied together should give us back our original answer. But yeah, so we know it divides in evenly, so we know all this remainder is actually equal to 0. And we can use that to our advantage because we can express c in terms of b. So if we take our b's to one side and all our c's to one side, minus c plus 6c squared plus 6 minus 6c equals 6b squared. We can divide everything by 6. Minus c plus c squared plus 1 minus c equals b squared. We can add together our c's, so c squared minus 2c plus 1 equals b squared. Factorize this, c, 1 minus minus. So that's c minus 1 squared equals b squared. So that's square root of c minus 1 squared equals b. And we know square root is kind of just the opposite of squaring. So this is just c minus 1 equals b. And we've actually got this backwards. So we're expressing c in terms of b. So we want c alone and b plus 1. So that could cost you a mark at the end if you're not careful. So when it says c in terms of, that means c is on its own. So yeah, factors divided into expressions give a remainder of 0, and factors multiplied by another factor give an expression. But what I also showed you was another way of doing this, which involved using the definition of the word factor, and that was changing a factor into a root. So if factors multiplied by each other give expressions, factor to expression, then roots subbed into expressions, subbed into, I'll just write exp, give you 0. And now you can see that it's closely related, like because factors divided into expressions give a remainder of 0, roots subbed into expressions give a remainder of 0. So you can see they're kind of at least closely related, and that's because you can turn a factor into a root just by letting it equal to 0. So if our factor was x minus c plus 1, if we let that equal to 0 and get x on its own, that's c minus 1, we know that this is now a root. And if we sub a root into an expression, we should get 0. So if we rewrite the expression they gave us, x squared minus 5x plus 5cx minus cb squared, this is just the expression they gave at the start, and we sub in our value for x, we should end up with this thing equal to 0. So that's what we're going to do. We're going to sub in x. So wherever we see x, we'll just sub in c minus 1. So x squared is actually c minus 1 squared minus 5 times c minus 1 plus 5c times c minus 1 minus 6b squared. And because we subbed in a root, we know all that's equal to 0. So when you're squaring something like this, what you can do is you can square the first, add twice the two multiplied together, and then square the last. So what that would look like is c squared, then add 2 times them multiplied together, so minus 1 times c, and then square the last, so minus 1 squared. And what you're left with is c squared, I'll put that back on black, c squared minus 2c plus 1. Now we'll move on to our next term, so minus 5 times c is just minus 5c, minus 5 times 1, no, minus 5 times minus 1 is plus 5. 5c times c is 5c squared. 5c times minus 1 is minus 5c, and nothing happened to the 6b squared. All that's equal to 0. So if we go ahead and start reorganizing and put our highest power of c first, that's c squared plus 5c squared, then just all our c's, minus 2c minus 5c minus 5c, and then just our constants and 6b squared. That's all equals 0. So we can start adding. C squared plus 5c squared is 6c squared, minus 2c minus 5c minus 5c is minus 12c, and have I forgotten a 5? I forgot a 5. So I'll just move this. I forgot this 5 up here. So 1 plus 5 is 6 minus 6b squared equal to 0. We can divide everything by 6. C squared minus 2c plus 1 minus b squared equals 0. We can isolate everything. So bring your b's to one side. And we can factorize 1 minus minus. So that's c minus 1 squared equals b squared. And we can just get rid of those. So that would be the same as square rooting each side, but we know that those cancel anyway. So we can just write c minus 1 equals b. And again, you can see this is the same answer. So c equals b plus 1. So basically, I chose this question because I want to get across to you that factors and roots are related, and you can change a factor into a root by letting it equal to 0. And then subbing a root into an expression gives 0. So that's basically 2 ways of doing it, but both give you the same answer. So on to the next question. So next, I think we had this question. So the function f is such that f of x is equal to this, where x is just any real number, including irrationals like root 2 and stuff, but that doesn't really matter. You can just ignore that. Show that x equals minus 3 is a root of f of x, and find the other 2 roots. So, a brief thing on functions. A function is a rule that gives you an output. So this is your rule, and this is your output. And like I was saying the other day, we can see this easily by if instead of the y-axis, we just put our output, and we have x on the x-axis. So if our function was, say, f of x equals 2x plus 1, whatever we sub in for x, so x equals 1, f of 1 equals 2 times 1 plus 1, that's equal to 3 plus 1 is equal, or 2 plus 1, sorry, and that's equal to 3. So when we subbed in x equal to 1, we got an output of 3. F of 1 is 3. That's our output. So this would be the same as going across 1 tick on the x-axis, and this would correspond to an output of 3 ticks on the y-axis, or the output axis. The reason you can do this is because most questions will say f of x is equal to y, and that's where it can get kind of confusing, because sometimes you can see y equals 2x plus 1 instead of f of x plus 2x plus 1, but really they're the same thing, because people will put the output on the y-axis and then graph the curve. So then if we say did this for f of 2, that's 2 times 2 plus 1, that's 5. F of 3 equals 2 times 3 plus 1, that's 7. You can see if you did this for all values of x, you'd get some kind of curve along your graph. And basically how you would read this is whatever value you pick along the x-axis, if you went to here and say we went to 7, you would go up, and wherever it hits this curve, go across, and this would be your output. So f at 7, whatever that is. So if we figure that out, that's f of 7 equals 2 times 7 plus 1, that's 15. So this would actually be 15 over here. So that's graphing a function. But keep this in your mind. A function is a rule, and that gives you an output. That's all you need to remember. You put in x, you get a value for x. That's all. That's the same thing, just graphed over here. You put in x equal to 8, you go up and you get a value for f of 8. So, small thing on functions, but on to the question. So, the function f, we know what this is now. That's just a rule for giving us an output of x, and we want to show that x minus 3 is a root of f of x. So like I was saying before, roots, when subbed into expressions, give you 0. So what this would translate to into function terminology would be, so this is our expression. If we subbed in x equals minus 3, our output would be 0. It's all basically the same thing, just with different words. So like we were doing before, roots subbed into expressions give you 0. But here it's just that our output is 0. Exact same thing, different words. They're just trying to confuse you. But if how we're going to show that it's a root is we're going to sub it in and see if it's equal to 0. And if it is equal to 0, then it's definitely a root, and we've shown it. So f of x is equal to 2x cubed plus 5x squared minus 4x minus 3. We sub in our root, f of minus 3 equals wherever you see x, we're subbing in 3, minus 3 cubed plus 5 times minus 3 squared minus 4 times minus 3 minus 3. And so we can multiply all this out. I'll just rewrite all this to make it a bit easier to understand. Anything cubed is just itself multiplied 3 times. Anything squared is itself multiplied twice. And this is all the same, minus 3. So minus 3 times minus 3 is positive 9. Positive 9 times minus 3 is minus 27. So 2 times minus 27 plus 5 times minus 3 times minus 3 is positive 9. Minus 4 times minus 3 is positive 12, and minus 3. So 2 times minus 27, that's minus 54. 5 times 9 is plus 45, and plus 12 minus 3. And that's equal to 0. And we know because f of minus 3 is equal to 0, we know that minus 3 is a root. And so we've done the first part, we've shown that minus 3, x equals minus 3, is a root of this function or this expression. So now, how are we going to find the other two roots? Well, we can do that by long division like we did before. And how we can do that is turning this root into a factor. So I chose this question because before we turned a factor into a root, and now we're going to turn a root into a factor. So how did we turn a factor into a root? Say we had x minus 3 was a factor. What we did, we let it equal to 0 and saw what x was equal to, and this was our root. So we're just going to do the opposite. Turn this back into a factor. We're just going to let it equal to 0, so bring this minus 3 back, and so that's x minus 3 equal to 0. So they're kind of one and the same, like it's pretty easy. So if x equals minus 3 is a root, I'm going to bring this 3 back across. That's x plus 3 equal to 0 is a factor. And so we know that factors divided into expressions is equal, dividing evenly, give a remainder of 0. So that's what we're going to use. We're going to divide into our expression, and we're going to get an answer up here and 0 down here. And this is going to be a quadratic. We're going to factorize it and get our two other factors. So first term into the first term, x into 2x cubed is 2x squared. Multiply this back, 2x squared times x is 2x cubed. 2x squared times 3 is 6x squared. Change your signs. Add those two lines together, those will cancel. This will be minus x squared. Bring down your remainders. Minus 4x minus 3. First term into first term. X into minus x squared is minus x. Multiply back. Minus x times x is minus x squared. Minus x times 3 is minus 3x. Change your signs. Positive, positive. Add your lines together. Those will cancel. This will give you minus x. Bring down this. That's minus 3. First term into the first term. That's just minus 1. Minus 1 times x. Minus x. Minus 1 times 3. Minus 3. And you can see that's going to be equal to 0. So we divided our factor into our expression. Got a remainder of 0. So this must mean that this in the brackets times x plus 3 gives us our expression. So we know that this is made up of factors. We know that x plus 3 times 2x squared minus x minus 1 is equal to 2x cubed plus 5x squared minus 4x minus 3, the expression that they give us at the start. So this times this is equal to that. And we know that factors multiplied by each other will give the expression. So we know that this is also going to be made up of factors. So we can factorize this. 2x, x, 1, 1. We want to end up with minus 1. So minus 2 plus 1. So 2x minus 1 times x plus 1 times x plus 3 will give us 2x cubed plus 5x squared minus 4x minus 3, our original expression, because factors multiplied by each other give expressions. But they're looking for the other two roots, and we have factors. So we know these are the other two factors. You have to change them back into roots. So if 2x minus 1 is a factor, then let it equal to 0. X equals a half is a root. And if x plus 1 is a factor, let it equal to 0. X equals minus 1 is a root. So our three roots are x equals minus 3, x equals a half, x equals minus 1. And write this at the bottom of your question. That's your final answer. And so we'll see this in the next question, but I'll just explain briefly on it. I said in the grind that, remember when we were graphing functions? So if, I'll try to get this right. Yeah, that looks right. If this is our function on the output, this is our x, and this is, remember I was saying you go across, you get an output, you get an answer for f of wherever x is. And we know that roots subbed into the function gives 0. So where is the function equal to 0? Well, it's equal to 0 here. It has a height of 0. If you went across to this point here and said, what's the value of the function at this point? Well, you have no height to go up and check. Here you'd have a height and you go across. Here you'd have a height. Here you're already on the floor. You go across. This here is 0. So where the function is equal to 0 is where it crosses the x-axis. And where the function is equal to 0 is when you sub in the roots. So we can see that this is -3, this is 1, and this is a half in terms of x coordinates. And we'll see that in the next question. So this is your final answer. On to the next question. So this was our final question. We'll get to this. If I've forgotten any, like I said before, let me know. I'll do in the next video. And I know you wanted to go through a homework question. If we don't ever get to anything like that in the grind, just send me a picture of it. It'll probably take 2 seconds. I'll send you back an answer, and you can check that with what you did and see if it works. So yeah, but final question. Examine the graph of the polynomial shown. Write down the polynomial for the graph in this form here, where a, b, and c are just numbers. So what I was saying before, when you're graphing a function, if this is your output, this is your input, what you would call this shape is a polynomial, and different polynomials have different shapes. So this is a quadratic, this is a cubic. It's just terms and words. You'll probably go through them in your maths classes, but it's just another word for when you graph the function. It's equal to a polynomial. So when you graph an expression, or you graph a function, the shape it makes is a polynomial. But what I was saying before, what do we know about this graph here? Well, if we look at it, we can know where it crosses the x-axis, like I was saying before. And anything that crosses the x-axis is a root. So x equals -2 and x equals 4 are roots. And we can turn them into factors like we saw before. If we just bring that 2 across, x plus 2 is a factor, and x minus 4 is a factor. Now I've left out this one here on purpose because we'll get to that in a minute, but we know these two multiplied by some third factor will give us something that looks like that. And we just got to figure out what this is. And we're kind of almost there. We can do the same trick. We can look at where it crosses the x-axis, but this one doesn't cross the x-axis. It kind of touches it and then bounces back. But the way I like to think of this is, imagine it's crossing it and then crossing it immediately again. And wherever it crosses the x-axis is a root. So if this is 1, so that's x equal to 1. If we change this into a factor, that's x minus 1. But because it crossed it, that means it's a root, and it crossed it again. So that means there's another x minus 1. It crossed it twice. And we can write that pretty easily by x minus 1 squared, where just the x minus 1 is squared. So we know that this factor times this factor times this factor will give us a polynomial that will look like this when written out algebraically. So why don't we do that? And we're looking for a, b, and c, so when we do that, we can just compare the coefficients of each term and see what the numbers are. So let's just hop into it. X times x is x squared. X times minus 4 is minus 4x. 2 times x is 2x. 2 times minus 4 is minus 8. Times x minus 1 to be squared. So I've just left this one till last because it's pretty tricky. So we can add these two. That's x squared minus 2x minus 8 times anything squared is just itself times itself. And we can see, or you can do that trick I was saying, x squared times twice the product times minus 1 squared. But I'll just write it out just so if you find that real tricky, we'll see. But x times x, x squared, x times minus 1, minus 1x, minus 1 times x, minus 1x, minus 1 times minus 1, positive 1. So all that times x squared minus 2x minus 8. And we can add these, x squared minus 2x minus 8 times x squared minus 2x plus 1. So you can see here, this is the same rule that we did before. We squared x squared, we added twice minus 1 times x, that's minus 2x, and we squared the minus 1 at the end, that's just regular 1. But if you find that hard, you can write it, just multiply it by itself, and then write it out, and then add together your terms, and you get the same answer. But we'll keep going. X times x squared, x to the 4, because you add your indices. X times minus 2x, or x squared times minus 2x is minus 2x cubed. You add your indices again. So imagine this was 1. X squared times 1 is just x squared. Minus 2 times x squared is minus 2x squared. Minus 2 times minus 2x is positive 4x squared minus, this one should be cubed, sorry. And minus 2x times 1 is just minus 2x. Minus 8 times minus x squared. Minus 8 times minus 2x. And minus 8 times 1 is minus 8. So we'll write our highest ones first, x to the power 4. We have no other x to the power 4s. We'll go with our x to the power 3s. No other x to the power 3s. We'll do our x to the power 2s. 4x squared minus 8x squared. We have no more after that. Then we'll do our regular x's, minus 2x plus 16x minus 8. And then we can start adding stuff. So x to the 4 minus 2x cubed minus 2x cubed is minus 4x cubed. X squared plus 4x squared is 5x squared. Minus 8x squared is minus 3x squared. Then minus 2x plus 16x is 14x, and minus 8 is just there. So this is basically our question pretty much done, almost. It wanted it in this form. Oh no, that is the question done. Sometimes it'll ask you what are A, what are B, what are C, and you'll have to write the answers. But all you do there is just look at the coefficients of each, and A is obviously 1, B is minus 4, minus 3, and so on and so on. But this question, they just wanted you to write it like this. So that's your final question. So take away from this question, where across the x-axis is a root, you can turn a root into a factor. Factors multiplied by each other give the expression. All the stuff we could have been saying. Additional knowledge, where it touches and bounces off, think of that like crossing and crossing again. So there should be 2 of them. So it's squared. So that's your takeaway from this question. Yeah, so I think that's all the questions we got to in the maths grind. Let me know if you have any questions, and I'll see you on Monday.